Hello, my name is Juan Nunez. I'm the practice leader for the data analytics practice at MicroStrategies, and I am joined today by Dr. Mark Antonio Awada. And welcome, Mark Antonio. I'm so excited you're going to be joining us in our upcoming webinar series in the first session. So Mark Antonio, for folks to get to know you a little bit, very, very brief, you have such an interesting background. We're talking a professor of data science at Max Planck. You have a PhD in theoretical physics. You are currently the chief investment officer at a financial company. You have taught about applied quantitative finance at Harvard. And I'm sure that just barely scratches the surface on all the work that you do. And I think it's so very interesting, this combination of business and sort of commercial perspective as you think about data, and also the research and exploration and experimentation, and also helping train the next generation of data scientists. So very excited to talk to you, Mark Antonio.
Thank you, Juan. I really appreciate that, and thank you for inviting me for this, very informative and I'm sure very beautiful webinar that we are going to discuss very, very important topics. I think, before even we jump to data science, I just want to kind of draw an example that comes from my experience as a physicist. I mean, that's how I started my career, over 30 years ago, essentially doing the PhD and then go through the ranks until I became a professor in that. But the key in this is that as a theoretical physicist, what we strive for is to write down, theories and models that we hope it will describe nature, and its forces, from gravity to electromagnetism, and then to a unified version of them, for which actually the one I did the PhD with, he got the Nobel Prize for. But always at the heart of that, in terms of any model that you write down, you need, in the end of the day, to validate it, to verify it. Does it really, if it predicts something, is that prediction correct with nature? So that's the other venue of physics, experimental physics. And experimental physicists, what they do over time is that they design these machines, and they do what? They collect data and data and data. Why? Because that data is their means to communicate with nature. Yeah. And it is there where a model, either lives or dies. So essentially, experimental physics, in quotation, the data extraction from nature is what validates theoretical physics. Data has always been with us, way before this new, I'll say, revival of what we call data science. I mean, now what's differentiating about it is the fact that we have, powerful machines. We have even more data. We have everyday data. But data has been with us for decades, for centuries, even for millennia. Even if you go, anthropologists, when they go and look into a dinosaur, that stamp of that dinosaur that of 65 million years ago, that's data. That's an information. So what's ultimately the goal? The goal behind data is to extract information, and with a bit of luck, to build knowledge. That there is some sort of a knowledge that tells us something about nature or about a business company, or then you can do the attribution in a multi-variety of way. And I think this is the core importance of why data is something that we cannot just simply ignore, just by the fact that it doesn't have any sort of a formality or a pattern that can be put into an equation or can put it in an expression. It's all over. Yes, it's complex, but that's where the challenge is, to be able to kind of decipher that data, to extract that knowledge and that information out of it.
Yeah, such a critical point. Such a critical point. Look, I am so excited about our conversation next week. I'm so excited to have you join the rest of the panel and just watch you guys shine. We're really thankful for your time today, Mark Antonio.